All right, lesson 2.7 deals with quadratic application. Okay, so why have we been doing all the stuff we've been doing? It's for this lesson right here. When are you ever going to use this in real life? Here you go.
We'll find out.
Yep. Now we're gonna understand what we're doing. Okay, one of the most important things is most of the parabolas and quadratic functions we're going to be talking about are a parabola with a negative a, which means the parabola is going to open upside down. Okay, so that's going to be the majority of the problems we work with is an upside down parabola, okay, where we have maximum things.
Gravity.
So this word, yep, we'll deal a lot with gravity. This word, maximum height, is going to be incredibly important. Whenever you see the word maximum, you should begin using this formula. All right? So whenever you see the word maximum, you should begin the problem automatically by doing the opposite of b over 2a. Because would you agree that this point right here on my parabola is the maximum, right? It's also the vertex. And so the way we find the vertex, remember, is doing the opposite of b over 2a, right? That's how we find our vertex. Okay, so not only are we finding our vertex, but we're also finding the maximum of something, whether it's price or the height, which is the majority of what we're going to work with. Okay, so we're going to use opposite of b over 2a. The h value in our vertex represents the time that it takes to get to the maximum height. The k value represents the actual height. So if it asks you to find the time that it takes to get to the maximum height, you're going to just be looking for the h value. If it asks you to find the actual maximum height, you're going to have to plug the h back in and find k. You guys remember doing that, plugging h back in to find k for your vertex? Okay. So let's do an example. And again, I do these examples with you because I wrote your homework assignment, right? And so the homework assignment parallels your notes. So when you get to your homework, you don't need to say, I don't know how to do this, because you need to look back at your homework or your notes. All right? Okay, so the first example says, Zach throws a melon upward from the top of a 1,200-foot tall building. The height of the melon, t seconds after he threw it, is represented by this equation. Now, one of the things that I'm going to ask you to do is to draw a representation of what this looks like. Okay? So in math, a picture screams 1,000 words. Yeah, screams. Not just says, but screams. Okay, so we're going to build a building here. Off to the side, this is my building.
Good building.
Here is Zach.
Just casually dropping melons from the top of the building.
Just casually dropping melons, yep.
He's throwing.
We know that this height is 1,200 feet. Okay, so the building is 1,200 feet tall. I know that. And he's throwing a melon. So we're going to assume that Zach has lots of muscles because the melon's going to go up first and then down. I think if I tried to throw a melon, it would just go down. Right? Like I don't have a lot of oomph to get it up and then down. So we're just going to pretend that Zach has a lot of muscles. Let me draw just a muscle here for you.
We'll just go with it.
You can kind of see his muscles there on his arms. All right. So it says, how long does it take for the melon to reach maximum height? The first thing to do with story problems, because students always say story problems are the thing that drive them crazy and we don't know how to figure them out. So look at the first two words here. Please do not be working ahead. I see some pencils moving. You should not be working ahead. How long is asking for time or is it asking for height?
Time.
How long? That's time, right? So this is asking you for time, which is the h value, right? How long does it take for the melon to reach the maximum height? And I said anytime you see the word maximum height, you should be doing what?
Negative b over 2a.
Negative b over 2a. All right? So I'm going to do x equals negative b over 2a. And I'm going to pull that information from the equation that they gave me in the story problem. So the opposite of b is going to be negative 160 over 2 times negative 16. Okay, you can use your calculator to help you there. If you don't have your calculator, you need to hop up and get it quickly. So negative 160 over negative 32, what does that reduce to? Anthony? Left. Okay. Crystal, what does that reduce to?
That reduces to 5.
5. Okay, what does this 5 mean? Isn't this the h value of our vertex? Right? It is the h value of our vertex. And the h value is the time. So what does this mean?
It took 5 increments of time to
What's
get-
our increment? Do we have increments? Look right here. We have seconds right here, right? Okay, so it took 5 seconds to do what?
reach its maximum height.
For the
Okay.
melon to reach its peak.
Here's the thing. We're going to write complete sentences for these story problems, and so if you don't know how to write complete sentences for story problems, all you're doing is repeating the question. How long does it take to reach maximum height? It takes 5 seconds to reach maximum height. It takes 5 seconds to reach maximum height. That means over here on my drawing and on your drawing, we know that this is 5 comma something. That's what that means there. 5 comma something. Okay, letter B says, what is the maximum height? So again, I see the words maximum height, but this time it's asking me what is the maximum height. So it's actually asking me for the height, which is the k value. If we know h from the previous problem, how do we find the k value of our vertex? Plug it back into your problem, right? Do you guys remember this when we were graphing parabolas? You found the first x coordinate and then you plugged it back in? This is the same concept here. Okay, so I'm going to take my equation, negative 16, but instead of a t, I'm going to put my 5 squared. I'm using the formula from the problem. Anybody have questions where this came from? If you need to make yourself a note off to the side, you can say plug 5 back in. We are finding h of 5. What are we getting?
1,600 feet.
I have 1,600 over here. Anybody else? 1,600. Kind of feel like an auctioneer here. 1,600, could I hear 1,600? 1,600?
1,600 for pay.
Yeah. Okay, so 25 times negative 16 is a negative 400 plus 800 plus 1,200. Should give you 1,600. Now, if you are looking at this right here, this says when you plug a 5 in, when you plug 5 seconds in, you get 1,600 feet. That's what this h of 5 equals 1,600 means. So how are we going to answer our questions? Our question. What, Quentin? Okay, what's it going to be? Excellent. The max height
Of the melon.
of the melon is 1,600 feet. The max height of the melon is 1,600 feet. Okay, questions so far? All right, example C says, how far off the ground is the melon after 3 seconds? Okay, so let's just think about that. How far off the ground? Are they asking me to find time, or are they asking me to find the height in letter C? Height, right? How far off the ground? So this is asking me for the height of something. Because if we don't understand where we're going, we're not going to know how to get there. How far off the ground is the melon after 3 seconds? 3 seconds is giving you the time, right? Aren't they telling you that the time is 3? So how might we figure out what the height is, Josh? Okay. Anybody else?
Like, off the ground or off top of the building being the ground?
Off the ground. So, Josh, I'm coming back to you. What if we know that time is 3, that means our t is 3, where might we be able to plug that? Is the 3 representing our h, or is the 3 representing our time? Time. So we might plug it in for what instead of h? Perfect. Okay, so we're going to plug 3 in for our t. So let's write it like this. H of 3 equals, and then we're just substituting a 3 in for the t each place in the equation. Okay, so you guys can go ahead and plug that into your equation in each place. Chelsea, what'd you get?
I got
1,536. Anybody else echo Chelsea?
Yep.
Excellent. Okay, Chelsea, what does that 1,536 mean?
How far off the ground the melon is?
Okay, after what?
3 seconds.
Perfect. So that's going to kind of be our sentence, right? So after 3 seconds, the melon is 1,536 feet off the ground. After 3 seconds, the melon is 1,536 feet off the ground.
I have 1531.
Ooh, let me see your calculator. So not 100, negative 149. Should be 144. All right, any questions about letter C? Okay, letter D, it says, how long does it take for the melon to hit the ground? All right, so what's it asking us? How long? It's asking us for time when the melon hits the ground. Okay, if the melon is on the ground, how tall are we? Are we off the ground at all? No, so what's our height if the melon is on the ground? 0. So we know that our height is 0. So in this problem, we know our height is 0, so we're going to substitute 0 in for the entire h of t thing. So when it is on the ground, we are setting our height equal to 0. And if we are setting our height equal to 0, what are we going to do first? What are we going to do? Not plug in the, well, we're plugging in the 0 for our height. Factor, right? Remember, this is why we spent all that time factoring, was because if we set it equal to 0, then we can begin factoring. Now, I don't know about you, but x factoring 16 times 1200 is going to be a bear, right? That's going to be a nightmare. What can we do first? Greatest common factor, and the hint is that the 16 should probably come out. So let's divide each of those things and see if we can divide each of those things by 16. We for sure can do the first and the second. Does 1200 divide by 16? Yeah? Okay? Now, here's a hint. Do we want t squared to be positive or negative? Do we want the t squared value to be positive or negative? Positive. So let's divide a negative 16 out. Let's factor out a negative 16 from the whole problem.
You can't have negative time.
You can't have negative time, but we're not there yet. We're just factoring. So we are going to divide the entire problem by a negative 16, but whatever you do on one side, you have to do on the other. But what is 0 divided by anything? 0. That's why it appears as though the negative 16 just goes away. That's why it appears that way. It doesn't, because we know that 0 divided by anything is 0. So then I'm left with t squared minus 10t minus 75. Is that what you guys have?
Yeah.
All right. You should be able to factor this for sure. Right? So we're going to set up our x factor. What two numbers multiply to get a negative 75 and add to get a negative 10? Please don't shout it out. Work it for a minute. Some of you still need a calculator because you don't have one in front of you. James. Anybody find the factors? What is it, Tish? 5 and negative 15. Okay, so I have t plus 5, and I have t minus 15. So what do I do with each of these things? Good, Chelsea. Set them each equal to 0.
You have t squared plus 5, don't you?
I have just t plus 5.
Why?
Because when we factor the t squared, it goes 1 in each parenthesis. Remember factoring? The t gets split between the two parentheses. That's why it's important to keep up with your homework on time and keep doing it. What does t represent in this problem? Time. Okay, can you have a negative time? You can't, can you? So negative 5 seconds is not going to do us any good. So our only answer here is what, Amanda? 15. Can you give me the sentence that goes along with it? Perfect. It takes 15 seconds for the melon to hit the ground. That's what you're going to write, and I'll write it too. It takes 15 seconds for the melon to hit the ground. How do you feel about this? Questions so far?
Why are you stealing those things?
Well, I am not. Zach is, and now Miss Brandy is.
Yeah, he's baseball pitching.
Okay, let's look at example 2. So we're going to do the kind of the exact same thing here. Okay. It says Miss Brandy is standing on the top of a 1,680-foot cliff. She throws a baseball upwards. Miss Brandy likes softball, so she's got a good arm. At every second, she measures the distance of the object from the ground. exactly t seconds after she threw the ball, the height in feet is measured by the following equation. It looks very similar to it. Does anybody know why it's negative 16t squared? Anybody know like why that keeps coming up? It's not random.
I forget.
Negative 16t is time, you're right. Negative 16t squared has to do with the physics of gravity. Like it's a staple, right? And so anytime you're throwing something up in the air and it's coming down, you're going to use negative 16t squared. All right, so it says, in this case, just find h of 3. So h of 3, remember, represents the object's positions 3 seconds after we threw it. So they're telling us what to do here. Find h of 3. Okay? So we are going to do what with that 3, do you think? For what? Good. Go ahead and plug 3 in for t in each spot. Give me an answer, and I want you to give me a sentence after that, please. Plug your 3 in.
I didn't draw a picture.
Okay, now plug your 3 in.
Okay, I did.
You didn't.
I did. Sorry, but I done did.
Chris, you look ready to give me your answer, so I'm coming to you.
I don't know how to put the sentence, but I have the answer.
You don't know what?
I don't know how to put the sentence, but I have the answer.
Okay. What's your answer?
2,304.
2,304?
Yes.
Does anybody else agree with 2,304? Okay. So what happened? What did the 3 mean? What does the 3 mean?
Seconds.
3 seconds, right? So is the 2,304, is that height or is that seconds?
Height.
Okay. So if it's 3 seconds,
It takes 3 seconds to reach 2,304 feet.
perfect. It takes 3 seconds for the ball to reach 2,304 feet. Or you could say after 3 seconds, the ball is 2,304 feet in the air. Either one. That's a pretty high. That's a pretty high toss. Miss Brandy threw that thing 1,700 feet almost.
What a beast.
Wow. I don't think this is realistic, but
See, let's see how many miles per hour that is.
no, not right now. But that's pretty fast.
She's tossing these balls into orbit.
Right? Okay. The next question, part B, says, what is the maximum height of the ball? What's a key phrase there? Maximum height. What do we use? Anytime we see maximum height, what do we use? Yep. Negative b over 2a. Now we have to decide, do we want the h value or do we want the k value? And it says, what is the height? Right? So is it asking me for the h or the k?
Okay.
The k value. But in order to find k, you have to find the h first, right? So we're going to start part B with the opposite of b over 2a. Then when we get that answer, then we'll plug it back in. So why don't you go ahead and take a few minutes to do that. Start with the opposite of b over 2a. Use your calculator to help. Patrick, do you have a question? Oh, move your finger up.
Eight.
Okay. 8 is the number of seconds, right?
Yeah.
So we're getting 8
But
negative
for the
256 over 2 times negative 16 gives me 8. We're not finished. That's only halfway through, right? Now what do we need to do with this 8? Austin?
Plug it in for T.
Plug it back in for T. Okay, go ahead and plug in the 8 in for T to figure out what's going on, where the height is after 8 seconds.
It's probably gone by now.
Lost in orbit somewhere?
Yep. I wonder how many space shuttles this thing destroyed.
Okay, Hortensia, I'm coming to you for this answer. You can check with your neighbor to double check. Boy, what did they do without calculators in our lives, huh? You have all the olden days. Actually had to use your brain to think about it, right? What happened?
I didn't come.
Okay, when we plug an 8 in, Hortensia, what did you get when you plugged an 8 in to your equation? 2,704. Does anyone agree with Hortensia?
Yes.
Okay,
I
I
do.
would. I would agree with that. Okay, if you did not get 2,704, you have a math error somewhere. Maybe check with your neighbor, see what happened. Hortensia, what's the sentence?
The maximum height of the wall is 2,704.
Perfect. The max height of the ball. For extra credit, you can put after 8 seconds if you'd like to. The max height of the ball is 2,704 feet. Give him a
I
nudge.
don't have room.
There you go.
I don't have room to write in here.
Okay, you can write down the side of your paper. You're welcome to do that. You think I'm going to let you out of it? No. All right. Let's do letter C now. How much does the object travel during the 2 seconds between 5 seconds and 7 seconds? This is kind of a loaded question. How much does the object travel between the 2 seconds, 5, and 7? Anybody have an idea how we might start this one? Wouldn't add the 7 and the 5 together. Josh?
Well, since we already know how long it was, 3 seconds after they drew, can you just double that?
But is it happening at the same speed each time? Every second, is it going at the same speed? Would you agree if I figured out the time, look over here at this picture up here. If I figured out the time from here to here and I knew how tall it was here and here, if this was 300, for example, and this was 500, how much did it travel from here to here?
200.
What did we do? We didn't add, we subtracted. We found the height when it was here, and we found the height when it was here, and then we subtracted. So we need to find 2 heights, right? So I'm going to find the height after 5 seconds and find the height after 7 seconds. So we need to find each height. So this is the same process again. So we're going to do h of 5. And then h of 7. Go ahead and do this on your paper. H of 5 and h of 7. So we're just plugging in the 5 and we're plugging in the 7. Plug in the 5 into your equation, plug in the 7 to the equation. So you're finding h of 5 and h of 7. Lainey, what'd you get for your h of 5?
2560.
2,560. Emily, do you echo that h of 5, 2,560? Good. Okay, finish up your h of 7. Paula, what do you have for h of 7? 3,360? I have 2,688.
93.
Okay, so negative 16, 7 squared, plus 256 times 7, plus 1680. So I have negative 784, plus 1,792, plus 1680. Does anyone else have 2,688?
Yeah.
Okay, so how much does the ball travel between these two things? What do I need to do here, Crystal?
Subtract them.
Good, I'm going to subtract them. Okay, so that's the next step is to subtract 2,688 minus 2,560. Patrick, what do you get when you do that? $128. Anybody else agree? Okay, so who wants to give me my sentence? Perfect. Chelsea? Yes.
It takes 128. It takes 128.
You're getting there. Is it 128 seconds or is it feet?
Feet.
Feet. Okay, so I would say maybe the object travels. Okay, so I would say the object travels. Okay, you take it from there.
The object travels 128
Travels 128 feet. There you go. Keep going.
75.
Good. 5 and 7 seconds. Excellent. The object travels 128 feet between 5 and 7 seconds. Good. All right, letter D is a little bit different than one we've done so far. Okay, so let's look at D. It says, how long does it take for the object to reach a height of 2,640 feet? So it says how long, so it's asking me for time. And it gave me what? What in my equation up there, in problem number 2, what represents the height up there in your problem? Not on my board, but in your paper, because you can't see it on my board. An example 2,
1680.
1680 isn't the feet. Or
That's the height of the cliff.
Okay. What in that equation represents height? The h of t represents height. Okay, so when you have h of t representing the entire height, what we're going to do is we're going to take out this h of t, and instead of h of t, I'm going to write 2,640 equals my equation, negative 16t squared plus 256t plus 1680. So in this problem, they gave me the height. And so I put the height into the equation where height goes. How do we solve a problem when we have a t squared or a quadratic term? Any ideas? How we solve this problem? What do we always have to do? Think about what we've been doing the last few days. Before we factor, we have to make sure...
Everything's equal to 0.
Oh. She's really excited about that. Okay. We have to make sure it's equal to 0. So, Chris, what are we going to do to make sure that this is equal to 0?
Subtract 2,600.
Okay, we're going to subtract 2,640 from each side. So we are setting it equal to 0. Sorry I didn't give you very much space to work this problem. And 1680 minus 2640 on your calculator. What? Negative 960. Okay, James, what's our next step here? How do we solve for t when we set it equal to 0 and we have 3 terms? Starts with an f.
Factor it.
Okay, excellent. We're going to factor it. Now, if we tried to x factor 16 times 960, that's going to be exhausting. So we should do what first? Say it again, Tracy. Greatest common factor. Now, what did I tell you the hint was? The 16. So let's double check to make sure 16 is going to come out of each of those. And then let's pull what kind of 16 out. All right. I'm going to let you to it. Pull a negative 16t, or a negative 16, not the t, just negative 16 out, and then factor. You're going to divide negative 16 out of the whole problem, and then factor. Come on. Almost done.
Would do that.
We're going to choose a negative 6 and a negative 10. Would you guys agree?
Yep.
Okay, so I have t minus 6, t minus 10. Set each of these equal to 0, right? And I get t to be 6 and t to be 10. Which answer do I use?
It
Okay, Chelsea said maybe we could use both because we don't have a negative. Does anyone agree with that? You had to pick a side, right? Do you agree with that or do you not agree with that? Okay, let's think about this. If I am throwing an object up in the air and down, if this height right here is 2,640, isn't it hitting it on the way up and again on the way down?
Yes.
Right, so it can hit that, the object can hit that height twice, on the way up and on the way down, right? So I can use both seconds because they're both positive, and it's going to hit that height on the way up and it's going to hit that height on the way down. Does that make sense? All right, so then our sentence is going to be, the object will be at 2,640 feet after 6 and 10 seconds. All right, questions on that one? Again, I'm trying to do problems like you're going to have in your homework, okay? The wording is almost identical in your homework. We just changed some numbers. We're going to do part E, and then we're going to pause until tomorrow. I mean, I'm going to give you your assignment, and I want you to work on it, but we'll pick up our notes again tomorrow. Okay, I want you to try to do E on your own based on number 1, part D. Do part E based on number 1, part D. It says, how long does it take for the object to hit the ground? So I want you to look back on number 1, part D. Number 2, part E is the exact same type of problem. I want you to work on it, please. Don't just sit there staring at your paper without a pencil in your hand. Look back. Don't just sit there and look at me.
So the first thing to do is write the problem down. This is how long does it take for it to hit the ground? What does this mean when it hit the ground? What do we do? You skip this step, that's the problem. You didn't write this down, I don't know, you zoned out, whatever. We set this equation equal to 0, and then we factor out. So set this equation equal to 0, and then you're gonna factor. Your signs are messed up. How did that go from a negative to a positive? No. We don't have 960, we have 1680. But there's a problem. It looks very much the same as the other one. It's a different problem. Okay, did you expect a 105? Right, because if you were to multiply these two things back together, you're going to get a really big number.
So we have negative 105 and negative 16 that we have to x factor. Okay. Paula, what factors did you choose? 5 and negative 21. I would agree with that. So this is t plus 5, t minus 21. What do we do with each of those things? Set each of them equal to 0. So I get t to be negative 5 and t to be 21. And it's asking me for time, and can time ever be negative? No? So Colt, which answer do we want to use?
The right one.
The right one. Yes, which is which one?
Well, it takes the object 21 seconds to hit the ground.
Say that louder.
It takes the object 21 seconds to hit the ground.
Perfect. It takes the object 21 seconds to hit the ground. Perfect. It's got a long hang time, huh? Okay.
He's cheating, standing on this.
Does anyone have any questions on this? We're going to hold off on example 3 and 4 until tomorrow.